Good morning. Today's lesson is lesson 3.1. We're going to be talking about rational numbers and decimals. So I'm going to move myself over here and maybe shrink myself down just a little bit so you can see. So our objectives today are I can write rational numbers as decimals and I can write mixed numbers as decimals. We're working from 7NS2D and 7NS2B. 2D says convert a rational number to a decimal using long division. We're going to be doing that in this unit using a lot of division to convert our fractions into decimals. And we're going to know that the decimal form of a rational number terminates in zeros or eventually repeats. So we're going to divide until we get a remainder of 0 or until the number repeats. Understand that integers can be divided, provided that the divisor is not 0, and every quotient of integers with non-zero divisors is a rational number. I think the lawnmower is going on outside the school building. If p and q are integers, then negative p divided by q is equal to negative p divided by q, which is equal to p divided by negative q. That's just basically saying that you can put the negative sign on either number. Interpret quotients of, as it should say, rational numbers by describing real-world contexts. All right, I'm going to minimize myself. Let's get started. Here's your meme of the day. A lot of your faces look like that in class. Yes, they do. But I can't tell because your masks on. So let's move on. It's definition time. So this guy is thinking the indefinite continued progress of time. He's going the definition of time, right? Like I hope I continue to exist here with you for all of time. What is her response? Not the definition of time, but time for a definition. You be mixing it up like. What is a rational number? Here is our definition. A number that can be written as a fraction, as a ratio of two integers a and b, where b is not 0. And this guy says, I knew that definition, cat like. Okay, what does that even mean? Well, that means that any number, any fraction, find a spot here, let me make a box. Any fraction is a ratio. So such that we have an a certain number, we don't know what it is. We have a certain different number on the bottom. That is considered a ratio. Okay, and we can write a ratio as a decimal, right? And a rational number is a fraction. It is a ratio. And it also says that b cannot equal 0 because when you have b equaling 0, a over 0, that is undefined. You cannot do that. So just remember that. No 0 on the bottom. No 0 on the bottom. That is undefined. Okay? But you can have 0 on the top. That is okay. So you could have 0 divided by a. That is okay. Here comes our lawnmower again. So that is okay. Let me clear all my drawings. Let's move on. Here are some examples of rational numbers. 11 divided by 15. That's a rational number. That's a ratio. That's a fraction. Rational numbers are fractions or can be written as a fraction. 0.35, that is a rational number because that can be written as a fraction of 35 on the top. What's on the bottom? 100 on the bottom, correct. Okay, it's bad 35 over 100, but that's basic gist of it. And 2.4 repeating. So 2.44444444. You're going to learn that in 8th grade, but that's really 2 and 4 over 9. It's 2 and 4 ninths. So that can be written as a fraction. Square root of 4, that is also a fraction because that really truly equals 2. What number times itself will equal 4? Well, 2 times 2. So 2 is the square root of 4. -6 is a rational number. All negative numbers that can be written as a fraction are rational numbers. You can write -6 as -6 over 1. That is a rational number. It's a fraction. -2.71, that's a fraction, or can be, 2 and, or -2 and 71 over 100. That is a fraction, wouldn't you say? Of course you would say that. Are there more? 0 is also a rational number because you can write 0, let me go over here, 0 over some number, right? 0 over any number will give you the answer of 0. So that is also a fraction. Clear my drawings there. One more, 3.5, that's the same as, well, that's already a fraction, isn't it? Of course, so that is a rational number. Note that all these numbers can be rewritten as fractions, so they are all rational numbers. What does this say? These numbers are irrational. They cannot be written as a fraction. They do not repeat. They do not ever terminate. That means to end. They never, ever end. They go on forever and ever and ever and ever, and they don't repeat in a pattern. Pi is such a number. That number for pi, does anybody know what it is? What is pi? 3.14159265358979, etc. It doesn't have a pattern, it doesn't repeat, and it never ends. Your calculator, if you hit pi on there, will give you a certain length of the numbers, but your display only goes so far, so it will stop, but pi never stops. It's irrational. This number is irrational. Notice how it doesn't have a pattern. Nothing repeats in a pattern. You might have a couple 3s in there, but they don't repeat in any kind of a pattern. And the ... means it goes on forever and ever. Square root of 2 is an irrational number. Why? Because what number multiplied by itself will give you 2? Well, 1 times 1 isn't going to work, right? That's just going to give you 1. And 2 times 2 isn't going to work because that's just going to give you 4, right? So then you start saying, well, maybe it's between 1 and 2. So then you try 1.5 and you try that, 1.5 times 1.5. And what do you get? 1.5 times 1.5 should be 2.25. Yep, that gives you 2.25. That's closer, but it's still not 2. So then you say, oh, maybe I need to go down to 1.3. So you try 1.3 times 1.3. And what do you get? You get 1.3 times 1.3, 1.69. Well, that's under. So maybe it's 1.4, you say, right? And you can keep doing this. 1.4 happens to be 1.96. That's actually pretty close. So 1.4 times 1.4 is going to get you very close to the answer of 2 under the square root, but it's really 1.96. So you say, oh, well, maybe I could get a little closer if I did like 1.43 times 1.43. What would that give me? That's going to get me closer to 2, right? Eventually, I'm going to get there, right? So let's see. What does 1.43 times 1.43 give you? That gives you something closer. That gives you 2.0449. But you're still not exactly at 2. So then what do? Do you do 1.432 times 1.432? The point is you can never get exactly 2. You can get very, very close. You could get 1.9999999, but you can never really get 2 when you multiply the same number together. So that's why it's considered irrational. The same goes for any non-perfect square. So let's move on. More about rational numbers. Rational numbers can be converted into decimals. That's what we're going to be working on. There are two types of decimals that are rational. The first type are terminating decimals. Remember I said if it starts a pattern and repeats again, you can stop dividing, right? So that is a terminating decimal. They come to an end. That guy's the Terminator. If you ever saw that movie, the decimals come to an end. They terminate. The Terminator went around terminating people's lives. Okay. So 0.35 terminates. It ends. 0.35. That's it. There's nothing after the 5. It terminates. Then you have repeating decimals. So here's a parrot. One or more digits repeated infinitely. One or more digits repeat 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 infinitely. Goes on forever and ever and ever and ever, like a parrot repeating itself over and over and over again. So here's an example on the right there. 2.4 with a bar over the 4. Why is there a bar over the 4? Because that means 2.44444. I'm going to run out of screen space. 4, 4, and I'm going to put dot, 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 meaning it goes on forever and ever and ever. So the 4 repeats forever. Those are rational numbers. Both those types. Okay, it's your turn to try a couple questions. See you back in a moment. Welcome back. Hopefully you did well on those questions with rational numbers. Let's move on. Now we are going to learn how to convert rational numbers into decimals. You may already know how, but we're going to practice. So there is a rational number, 5/16. It's written as a fraction. We are going to convert it to a decimal. Waiting for my thing to show up. So the top number is going to go on the inside of our long division, which is over here on your right. And there's 5. That's our top number. That's going to go on the inside. And on the outside is going to go the bottom number of 16. There comes 16. Top number on the inside, bottom number on the outside. I don't care that the top number is smaller than the bottom. It still goes on the inside. We're going to use our acronym. Does McDonald's serve burgers? That is how we are going to use division, long division. So that means, type it down here, does stands for, wait, let's make it bigger here. Does stands for, we're going to divide first. Then M stands for, we're going to multiply second. S stands for, we're going to subtract third. And burger stands for, we're going to bring down if there's a number to bring down. So let's see what happens. Okay, we can't take 16 into 5, so we're going to add a 0.0. Notice how 5.0 is the same as 5. We haven't changed the number. 5.0 is the same. All we've done is add a 0. So now we're going to put the decimal point up on top. Hopefully I am doing that. Let's see. Yep, there it is. So there's our decimal point right up on top there. I made it nice and big for you to see it. It lines up exactly where the decimal is in the number. So lines up exactly right there. Okay, so our first step then is going to be to divide 16 into 50. I'm going to pretend now that we put our decimal up here like it's not there. So 16 into 50. If I don't know what number goes into 50, what number multiplies by 16 to give me 50, I'm going to write it on the side of my paper. And I'm going to say, oh, well, let's try 16 times 5. Maybe that would work. Or I could say, well, 20 is close to 16. It's probably going to be like 2 or something, but let's try 5. 5 times 6 is 30, carry the 3. 5 times 1 is 5, plus 3 is 8. 80 is way too much, right? So I'm going to clear that. Actually, keep it on your paper when you're doing this at home so that you have these to look back on. But we are going to try, I just don't have a lot of screen space, so I erased it. We're going to try 2. 16 times 2. And you're going to have to do this, and you'll get used to it. 2 times 6 is 12, plus it helps you with your multiplication. Carry the 1. 2 times 1 is 2 plus 1 is 3. 32. Am I as close to 50 as I can get? Well, just to be on the safe side, otherwise your whole problem is going to be wrong, try the next highest number to make sure that that number isn't closer to 50, but yet not over it. So 3 times 6 is 18. Carry the 1. 3 times 1 is 3 plus 1 is 4. 48. I'm really glad that I tried the 3. Why am I glad that I tried the 3? Because 48 is much closer to 50 than 32 is. So the answer is going to be a 3. So I'm going to put a 3 up on top. There it is. And now I go to the McDonald's part. Oh, I cleared all my drawings, so my acronym went away. Let's put it back if we can. Divide was first, and we did that. Now we're doing McDonald's. We're going to multiply, serve, then we're going to subtract, and finally we're going to bring down. Let's do that. Okay. So now we are going to multiply 3 times 16, and we already figured that out, right? That's why I don't erase it if you can help it. 3 times 16 is 48. Now we did does McDonald's. Now we're going to do serve or bring down. So I mean serve or subtract. What am I talking about? Subtract. 50 minus 48. So remember, when you're doing subtraction, you can't take an 8 from a 0. So you borrow from the 5 and make it a 4. And then the 0 becomes a 10. 10 minus 8. So 10 minus 8 is going to give you 2. And then 4 minus 4 is going to give you nothing. So there you go. 50 minus 48 is 2. Our last step then is to bring down. We have nothing to bring down, but we still have a remainder in our fraction that we're in our division, and nothing's repeated yet. So, or maybe it won't repeat. So we have to continue. So what do you think we do to continue? Is there something we can bring down? Yes, we're going to put another 0 in there, and we're going to bring that 0 down next to the 2. And we're going to start the does McDonald's serve burgers all over again. We're going to divide the 16. Let me get my spotlight here. We're going to divide the 16 into 20. So how many 16s will go into 20 without going over? We already decided that 2 times 16 was 32, so that was over. So it has to be less than 2. Right, it's 1. 16 times 1 is going to give us close. So we're going to get a 1 and we're going to put it right up here above the 0 we just added. And now we're on the McDonald's part, the multiply part. We're going to multiply 1 times 16. Don't multiply 31 times 16. We already took care of the 3. Just multiply 1 times 16. And you're going to write it below the 20. There's 16. Now we do the serve part, subtract. 20 minus 16. Again, you can't take a 6 from a 0, so you're going to cross off the 2 and make it a 1. You're borrowing, and you're going to make the 0 a 10. And you're going to subtract 10 minus 6 and get 4. And 1 minus 1 is nothing, so it's just going to be 4. There's your 4. Are we finished? No, we are not finished because we still have a remainder and nothing is repeating. So we have to do what? Start the process over again. We have to do burgers. We have to bring something down. So we're going to put another 0 there. And we're going to bring that down next to the 4. I like to put these little arrows even when I do this with my pencil because it helps me keep track of where the 0 is supposed to go. Because it could be really easy. Let me just get a different color here. It could be really easy to make a mistake and think that the 0 goes here. But it doesn't, right? It goes with the last number you have written there. So let me get rid of that because that's going to not be the case, right? We want to get rid of that. That's not where it goes. Okay, let's continue. We're going to divide again 16 into 40, or 40 divided by 16. How close can we get without going over? Well, we knew what 16 times 2 was 32. Did we do 16 times 3? Well, let's try it. 16 times 3. 3 times 6 is 18. Carry the 1. 3 times 1 is 3 plus 1 is 4, 48. That's too high. That's over 40. So it has to be 16 times 2. So let's erase this. So 16 times 2 was 32. We figured that out before. And on your paper, you'll have it written already, so it'll help you. You won't have to multiply again, right? So let's put our 2 in there. Now we do McDonald's or divide. 2 times 16. That gives us 32. We're going to write it down here. And now we're going to do serve or subtract. Here we are. We're going to subtract 40 minus 32 again. We can't take a 2 from a 0, so we're going to have to borrow from the 4 and make it a 3. And take the 1 we borrowed and put it over here and make it a 10. So 10 minus 2 is going to give us 8. There's our 8. Are we finished? We're not? Why not? Well, we still have a remainder. So what are we going to do? We're going to bring down a number. So we have to put another 0 there and bring it down. Again, I use my arrow so that I know I put my 0 next to my 8. Now we have to do 16 into 80. 80 divided by 16. And I think we figured that out earlier when we did 16 times 5. Remember when we did that? What did we get? 5 times 6 was 30. Put down the 0. Carry our 3. 5 times 1 is 5 plus 3 is 8. There's our 80. So 16 goes into 80 exactly 5 times. So let's put that there. There's 5 up at the top there. Again, it's above the last 0 we put there. And now we multiply 5 times 16. That gives us exactly 80. Now we subtract. And we finally get a remainder of 0, right? We finally get that 0. So now we can stop. We have a terminating decimal. The decimal ends at a specific point. This is not a repeating decimal. It's a terminating decimal. So there's our answer, 0.3125. You would say that as 3,125 10,000ths. This is your tenths place, hundredths place, thousandths place, 10,000ths place. You say 3,125 10,000ths with a TH at the end. Okay, that's how we're going to do our long division. I'm going to clear my drawings. Oh, we already answered that. Is this a terminating or repeating decimal? What did we say? Terminating, it ends, correct? It is a terminating decimal. Okay, let's move on to converting some more rational numbers into decimals, some more fractions into decimals. This time we have 13 over 33. Which number is going to go on the inside of our little division house? Top number on the inside. There's our division house. We're going to put 13 on the inside. Again, it doesn't matter that it's smaller than 33. We just know we're going to get a decimal answer that's less than 1. And isn't that kind of the definition of fractions? Usually they're less than 1 unless you have a mixed number. 33 is the bottom. That's going to go on the outside of my division house. There it is. And now I start the process. Does McDonald's serve burgers? Divide, multiply, subtract, bring down. Repeat. Divide, multiply, subtract, bring down. Repeat if we need to again. Divide, multiply, subtract, bring down. I should make a sound. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Anyways. So we can't take 33 into 13 because 13 is too small. 33 is way bigger than 13. So we have to add a decimal point and a 0. And then right away, I put the decimal point up above. Made it nice and big again for you so you can see it's supposed to line up right with the decimal in the number. Now we pretend like the decimal isn't here and we divide 33 into 130. So how many 33s go into 130? Well, I could say this is about 30, and I can easily multiply in my head with 30, right? 30, 60, 90, 120. So we could try 4, because 4 times 30 is 120, right? So now let's try 33, the real number. We were just doing an estimated number. And try 33 times 4. My guess is it'll probably work. 3 times 4 is 12, carry the 1. 3 times 4 is 12 plus 1 is 13. Oh, it almost works, but not quite. Why? Because 132 is just a little bit too high for 130. So we have to use 3. We have to go to 3 then. So we're going to do 33. And I do this on the side of my paper times 3, and we try that. What do we get? Well, you should get 3 times 3 is 9, and 3 times 3 is 9. So we get 99. So we're going to use 3. Again, at home, you don't have to erase your paper. I just have limited screen space. So we're going to put a 3 up on top. There it is, and we're putting it above the 0. Why above the 0? Because we took 33 into the whole 130. So this is the ending number of 130. So we start our answer above that number. Now we're going to do our multiply, which we did. 33 times 3, that's 99. Now we're going to do our subtract. 130 minus 99. Again, I can't take 9 into 0, so I'm borrowing from the 3. I'm making it a 2, and my 0 is going to become 10. Try to erase that extra little thing there. So now we have 10. So 10 minus 9 is going to be 1. We can't take a 9 from a 2, so we're going to borrow from the 1, make it a 0, and make the 2 a 12. 12 minus 9, that's going to be 3. So our subtraction will result in an answer of 31. I got to clear it because the computer is going to put it up there for us. There's our 31. Now we're not finished. We still have a remainder. So we're going to have to bring something down. There's nothing there to bring down. So we're going to add a 0 and bring down the 0 and put it next to the 31. So now we have to take 33 into 310. So I'm going to use 30 as my estimate. 30, 60, 90, 120, 150, 180, 210, etc., right? So I'm going to have a pretty big number probably with 310. So let's try a pretty big number. Let's try 9. Let's just see if that's over or that's close. 3 times 9 is 27, carry the 2. 3 times 9 is 27 plus 2, it's 29. That's as close as we're going to get. By the way, if you have to multiply by 10, you've done something wrong in the previous one. You didn't go high enough and close enough to the number. So it can't be any bigger than 9 no matter what, unless you've done something wrong. So if 10 works and that's still under your answer there, then you've done something wrong. So then you know to go back and try to fix it. So we're going to put a 9 up there, and then we're going to multiply 9, just the 9, times 33, which we have right here, is 297. So there's our 297. Now we do our subtract. And when we subtract this, you can't take a 7 from a 0, so you borrow. The 1 becomes a 0. And we borrow and bring the 1 over here. So 10 minus 7 is going to give us 3. Now we have to take 9, but we can't take it from 0, so we have to borrow from the 3 and make it a 2. And our 0 now becomes our 10. 10 minus 9 is 1. And then 2 minus 2 is going to be 0, so we don't really have to put that in. So 13 is the answer. Let's clear it and let our computer do that for us. It's going to put our number 13 in. There it is. Are we finished? No, because we still have a remainder. So we're going to put another 0 up there and bring it down. And now we have 130. How many 33s go into 130? Well, 30, 60, 90, 120, probably 4, right? Let's see, what did we have before when we did 33 times 4? I forgot. 3 times 4 was 12, carry the 1. 3 times 4 was 12 plus 1 was 132. Notice something? Didn't we have to do this before? You noticing something? Well, we'll see. We'll go a little further and see. So 4 is too high, so we have to put a 3 there. So let's put our 3 up there and then do our multiplying. 3 times 33 is going to give us 99. And now we're going to subtract. 130 minus 99 is going to give us 31. Something sounds familiar here. I'm not at a remainder yet, so I'm going to put another 0 and bring it down. And now I have 310. How many 33s go into 310? Well, didn't we figure that out already? Didn't we figure that out up here? Wasn't it 9? So we're going to put a 9 up there. We're going to multiply 9 times 33. That's going to give us 297. We are going to move myself up here. We are going to subtract, and that's going to give us 13. Well, if I put another 0 there, let's see if it does it. I'm going to end up with 130 again. Do you notice what's happening? I'm going to end up with 0.39393939393939 forever and ever, because it's going to keep repeating in this pattern. So I can stop dividing when I have a repeated decimal. Remember, when we either get to remainder of 0 or a repeating decimal, we can see this is going to keep repeating. So our answer is 0.39 with a line over the 3 and the 9. This bar over the line, over the number, means that 3 and 9 repeat. 39, 39, 39, 39. Okay, forever and ever and ever, just like our parrots. Okay, pretty good so far? All right, see what happens. Is this a terminating or repeating decimal? Is it a terminating decimal? Does it end? No, it doesn't end. It goes on forever and ever and ever and ever. 39, 39, 39, 39, 39, 39, 39. I could keep going on forever. So it is called a repeating decimal. Okay, you get to try long division. See you back in a minute. Welcome back. Let's keep going. Now we're going to divide mixed numbers into decimals, or we're going to write mixed numbers as decimals. Almost the same thing. 6 3/4, we want to write that as a mixed number. So you only need to divide the fractional part, just this part, when you are converting a mixed number into a decimal. Just don't forget to put the 6 over here, the whole number, in front of whatever decimal you get when you divide. Okay, don't forget to do that. If you forget to do that, your answer will be wrong. So 3 is going to go on the inside. Here it comes. There it is. And 4 is going to go on the outside. There it comes. All right. 3 divided by 4. Now we're going to do our Does McDonald's serve burgers? Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Okay, let's continue. So we can't take a 4 into a 3 because it's too small. 3 is too small. So we have to add a decimal point and a 0. We have not changed the number. It's still 3. But then I quickly put our decimal right at the top there, right in the right spot, right above the decimal where it's at in the 3. I continue. Now I can divide 4 into 30. So 4 times 9, that's 36, right? That's too high. 4 times 9 is 36. If you need to use your multiplication chart, please do so you can start memorizing your facts. Super important to get those memorized. 36 is too high, so we're going to try 4 times, what do you think? Yeah, 8. 4 times 8. And what is 4 times 8? That's 32. That's still too high, right? So then I'm going to go down to 4 times 7. What's 4 times 7? Memorize your facts. It's 28. 28 is very close to 30, but it isn't over. So I'm going to use 7. Yay for 7. There's 7 up there at the top. Now I'm going to multiply 4 times 7, which is 28. Put that under the 30. Now I'm going to serve or subtract. 30 minus 28 is, well, cross off the 3, make it a 2, make this a 10, right? We have to borrow. 10 minus 8 is 2. 2 minus nothing is just 0, so we don't have to do anything with that. So I'll let our computer put 2 in there. There it is. Now we're not done. We have a remainder. We're going to add another 0, correct? And burgers, bring down, put it right next to the 2. Now we have to take 4 into 20. 4 divided into 20. We start over with, does McDonald's serve burgers? How many 4s go into 20? 20 divided by 4 equals, or 4 times what equals 20 is another way of looking at division. 4 times something equals 20. What could it be? I hope you said 5. I hope you said 5. 5 is at the top. Now we multiply. 4 times 5 is 20. Now we subtract. We end up with a a remainder of 0. We are finished, sort of. Don't forget to add the 6 over here. Don't forget to add that 6 to the front of your decimal. So the final answer then is 6.75. Is that a terminating or is that a repeating decimal? Let's look. What do you think? 6.75. That's a terminating decimal. It ends after 5. Doesn't go on and on and on and on and on. So it's a terminating decimal. Okay. Okay, I think we're going to try another one here. Yes, with a word problem. Yvonne, that's how you say it. Yvonne bought a watermelon that weighed 7 1/3 pounds, right? 7 1/3 as a decimal. 7 1/3 as a decimal. Yvonne weighed her watermelon. Okay, 7 1/3. So here we go. There's 7 1/3. Remember, only divide the fractional part, the 1/3 part. And in the end, when we get our answer in a decimal, then we're going to add the 7 to the front of our number. Don't forget that. So the top number goes on the inside of our division house. And the bottom number goes on the outside of our division house. And then we start our dividing. Well, we can't take a 3 into a 1. Get my spotlight. Can't take a 3 into a 1. So what are we going to do? We're going to add a 0.0. Put my Does McDonald's at the bottom there for you. How many 3s go into 10? Well, first we have to put our decimal point there. And then we say, well, 3 times 4 is 12. That's too high. Then I can go to 3 times 3. And that's 9. So I'm going to put a 3 up there. 3, now we do multiply. 3 times 3 is 9. Now I do subtract. 10 minus 9 is 1. I'm not finished. I have a remainder. I'm going to put another 0 and bring it down. And I start over, dividing. 3 goes into 10. How many times? 3. 3 times 3 is 9. 10 minus 9 is 1. Do you notice what's going to happen or what is happening here? Do you notice? If I was to put another 0 there, it would just repeat again, wouldn't it? So my final answer then is 7.3 with a line over the 3 because my 3 goes on forever and ever and ever and it repeats continually. 7.33333333333333, right? And notice how I remember to put the 7 in front of my answer. Don't forget to put your 7 in front of your decimal after you've done your division. Don't forget that. Okay. Is this a terminating or repeating decimal? Well, we know the 3 goes on and on and on and on and on and on forever and ever, so it has to be a repeating decimal. Okay, your turn to give a mixed number a try. Make it into a decimal. Welcome back. Let's focus a little bit on some higher order thinking. I know you love these problems, right? Because they give you a chance to work in a little bit of a more advanced topic idea. So we have this little chart. We have 6th graders, 7th graders, and 8th graders. We have students who like video games and the number of students who do not like video games in each grade. So what are we going to be doing? We're going to write a ratio in the form A divided by B. Remember I said a ratio is a fraction. And then we're going to write it as a decimal for the number of 6th graders who like video games to the number of 7th graders who like video games. So we're making a ratio. So let me just do this for a sec. Let's find the number of 6th graders who like video games. So we're in this column here. Get my spotlight here. We're in this column, students who like video games, and we need the 6th graders. So which 6th graders like video games? 10 of them, right? And then we have to do the number of 7th graders who like video games. We're in the same column, but this time we're here. So we have to make a ratio, and when we do our ratio, it's a fraction. Another word for fraction is ratio. When we do our ratio, our fraction, we have to keep the order straight. So let me get a different color here. So we have to go to 6th graders first. They're going to have to go on the top. And the 7th graders are going to have to go on the bottom because that's how our problem is asking us to write the ratio. So we're going to put 10 on the top and we're going to put 15 on the bottom. And now we're able to make that into a fraction, right? 10/15. Some of you may notice that you can reduce 10/15, and you may. And if you do that, you'll still get the same decimal answer because 10/15 is equivalent to 2/3, right? If you know that, we're going to be talking about that later. But anyways, we got 10/15 for now. So clear my drawing because the computer put it up there for us, 10/15. And then we have to do our division. I don't know if I put the 10 in there or not. I did. 10 goes on the inside, 15 goes on the outside. And now I'm going to divide it. I don't think I divided, but let's see. So we can't take 15 into 10, so we're going to put a decimal and a 0. Right away, we're going to put our decimal up here. We're going to say, how many 15s will it take to get close to 100? How many can we get there? Well, we got to kind of estimate, right? So we can start with 15 times 5 and see what happens. 15 times 5. Remember, we're doing this on the side of our paper. 5 times 5 is 25, and we're going to carry our 2. 5 times 1 is 5 plus 2 is 7. That's 75. Can we get closer? I'm not sure. So I'm going to try 15 times 6 just in case I can get closer to 100 than 75 because I don't want to be wrong. If I don't use a big enough number, then I'm going to end up with getting a 10 in my next phase of my division. So 5 times 6 is 30, carry my 3. 6 times 1 is 6, plus 3 is 9, 90. It's pretty high. Do you think I could do another 15 times 7? I'm going to try it just to be sure I can't get any closer to 100. 5 times 7 is 35, and I'm going to carry my 3. 7 times 1 is 7, plus 3 is 10. So that's 105. Oops, I went over. So it has to be a 6. So let me erase my scribbly bop here. And now I subtract, right? I'm going to subtract. Well, I forgot to multiply. 15 times 6, what was it? Do you remember? That's why it's good not to erase your paper. 90, right? Remember it was 90? So let's put 90 here. Line your 90 up the right way. It doesn't go, your 9 doesn't start under your 1, right? That would be wrong. It starts under, go from right to left. Put the 0 under the 0, and then the 9 is under the 0. Now we do our subtract. So 0 minus 0 is 0. I can do that. And then I just have 10 minus 9, 1. So I have 1 and 0, right? Okay, I'm not at remainder 0, so I'm going to put another 0 here, and I'm going to bring down my 0. And notice what's happening. How many 15s go into 100? We figured that out, and we decided it was 6. 6 times 15 is going to give us 90. And we're going to subtract 100 minus 90 is going to give us 10. We still don't have a remainder. However, if I were to put another 0 here, and bring it down, I'm back to 100 again. Notice what's happening. Exactly. It's going to be 0.66666666666 forever and ever and repeat. So it's going to be 0.6 with a line over the 6 right here because the 6 repeats forever and ever. We have just found the ratio of 6th graders who like video games to the ratio of 7th graders who like video games. The answer is 0.66666 repeating. Okay. Oh, clear my drawings. See what's next. Focus on higher order thinking. Here we have a problem. Julie got 21 of the 23 questions on her math test correct. She got 29 of the 32 questions on her science test correct. On which test did she get a higher score? So first of all, can you compare 21 out of 23? By the way, that's how I figure your grade and your percentage. I see how many you got right out of how many questions or how many points it was worth. This is her math test. She got 21 correct out of 23. I've written a ratio of 21 on the top, 23 on the bottom. I've also written what you call a fraction. A fraction and a ratio are the same thing. And then on her science test, she had 29 questions correct out of 32, right? Can we compare these? Well, not exactly, right? Because why? Because science, S-C-I-E-N-C-E. Okay, why can't we compare them? Well, because our bottom numbers are not the same. We don't have the same number of questions. So 29 is not necessarily bigger than 31 questions, right? Because there were more questions on the science test. So the answer is no, we can't compare those fractions the way they are. We cannot. So the answer to the first part of the question is, can you compare the fractions? No. The denominators, the bottom numbers, have to be the same. The number of questions have to be the same, and they're not. So no. However, how could we compare her scores to see which one she got a higher grade on? I hope you said converting the fractions into decimals. Did you say that? I hope you did. Julie could convert, well, she should do it. She could, but she should convert each fraction into a decimal and compare them that way. So we would divide 21 on the inside divided by what on the outside? 23, right? And on the second one, for the science test, we would divide 29 on the inside by 32 on the outside. And that's how I get your grades as well. And then we would do our long division. So we'd have to put a 0.0 here and continue from there. And we'd have to put a 0.0 here and do our does McDonald's serve burgers, right? So I'm going to just show you the answer on this one. So actually this one is only an approximation. 21 divided by 23 will give you approximately 0.913, but it goes on for a really long time. It's one of those irrational numbers that doesn't repeat, doesn't terminate. So I just approximated it to be 0.913. That's the approximation of 91% about. On her science test, the approximation of 29 divided by 32 is 0.906. That one actually terminates. It's actually 0.90625, and then it stops. So we can compare it, though. We have enough information to compare. This is like a 90% on her science test and a 91% on her math test. So she did better on which one? She did better on her math test. Did you think that at first? I bet you weren't sure until you changed it to a decimal, right? If you hadn't changed it to a decimal, you would think maybe that the science test was bigger because it had a 29 on top, but that's not right because we weren't comparing the same number of questions. So she actually did better on her math test. Okay, next one. Is 0.1211221112222. If the pattern continues, is this going to be a repeating decimal? Is that a repeating decimal? Do you have an exact pattern of repeat? Like a certain number of numbers repeating over and over? No, right? This is 1, 2, and then it goes to 2 2s, and then it goes to 3 2s, and next time it'll go to 4 2s. The ones start with 1 1, 2 1s, 3 1s, and then it would go to 4 1s, etc., etc. So you would say no, although the digits follow some kind of a pattern, the same combination of digits does not repeat or do not repeat. The same combination do not repeat. Okay, give some of these harder problems a try and I'll see you back in a moment. Okay, I'm going to come back on here and I want to say your homework assignment will be on Google Classroom, lesson 3.1, and I will see you guys soon. Have a good day. Bye.